Humanity has come to dominate the planet and all of Earth's systems, but our omnipresence on this planet has caused quite a plethora of problems. Effectively, we need to change the way how we're running our planet towards more sustainable outcomes, like the Sustainable Development Goals that we see on the right. And each of these are affected by transformations, or can only take place through transformations of different sectors, as we see on the left. Yet the question remains, how do we change patterns of human behavior on this planet? Governance is a decisive factor as such in doing this, as it determines who can do what to whom and on whose authority. And governance, so to say, depends on the underlying institutions. By institutions, I mean prescriptions that humans use to organize humans effectively. So we're talking about, broadly speaking, rules, norms, and strategies that everyone applies every day in their lives to how human life is organized. One sector which is under a special focus here is agriculture, as it is important to our food security and very vulnerable to different social and ecological pressures. My special focus for my thesis was to look at seed systems, as literally nothing in this world grows without its seeds. And just to recap that for the purpose of this presentation, right? Seed systems are all activities that create new varieties for the use on farm. So we have a whole ton of different actors and materials, from genes to plants to plant plots to fields, involved in these systems. What we also need to realize is that seed systems as social-ecological systems are very interlinked, complex, adaptive system where ecological entities and social entities, aka the humans, so to say, come together and are inherently intertwined. And that's effectively what the definition of a social-ecological system is. And that effectively brings me to the title of my thesis, where I'm talking about the governance of plant breeding, a social-ecological systems perspective. So let's jump in. So effectively, we're going to take a little walk through the different theses chapter first, and then we're going to focus on 2 out of 5 and effectively talk about what kind of research methodologies I've used. And then we're going to go back to the big picture and take a little peek at the future. So as we said before, seed systems are comprised of the humans, and these are, in our case, science and pre-breeding scientists, applied breeders, multiplication and retail folks. And this one here has a little squeeze, because we're going to see later that this is going to be a bottleneck in the system. And then we have the farmers of the system who are, so to say, receiving and choosing the new varieties that are being created. And what this system feeds on is effectively crop genetic resources and varietal diversity. I have represented these as 2 here because different actors in the system call these different, use these different terms in order to communicate about how this material flows between the different actors and how it shapes crop genetic resources and varietal diversity. Effectively, the first chapter talked about what different governance challenges a seed system faces, and I focused on in situ crop genetic resources and varietal diversity, as that is, so to say, what's taking place in the field. Then chapter 3 took actually a step out from there and looked at developing a diagnostic procedure for nested resource system and network adjacent action situations, which is also in a way a fancy way of saying I compared seed systems to other resource systems that my co-authors are experts in, like water resource systems or forest resource systems. And effectively, we developed this diagnostic for large social-ecological systems where we can now compare how governance structures work across them. Got published in Sustainability Science. I was quite excited about that. Then the fourth chapter focused a little bit on the upper end of the breeding system and is more concerned with what mission-oriented governance, which is effectively the same philosophy that we took for rocket science in order to fly to the moon, plus robotics and automated phenotyping technology, means for the plans that we're trying to create for the future and how research policy influences that. And especially if it's also has a little bit of a reflection on how we can actually reach those sustainable development goals that we're talking about earlier. Then the last chapter that I wrote was on pest shocks on seed multiplication portfolios, where, haha, surprise, we were talking again about governance playing a vital role in this overall system. So, some of you might think, oh, good God, but what's going on with the details? The underlying trade-off that we face as researchers within these systemic views is that we have complexity. So we have a lot of details, but we don't want to make it too complicated, so to say, when we research in our research approaches, because otherwise we get incredibly lost. So I'm going to show you how I tackled that in two of my chapters. One is conducted qualitative research, and that for the governance challenges, and the other one was an impact evaluation where I looked at the impact of biotic shocks in a quantitative way. So for my qualitative research, the underlying research question for what are the governance challenges in appropriating and provisioning genetic diversity on site, right, in seed systems, effectively meant that I had to draw a system boundary somewhere and then start to interview and collect all, or more, not just interview, but collect all different types of data, from participant observation to open interviews to surveys and secondary data, in order to get a good sense of what actually happened, happens in seed systems every day. And I used for the interviews a sort of circular validation to elicit the system, where I used anonymized statements from one interview, brought them into the next interview in order to revalidate with the different actors in the systems what they think is true about the system and what, so to say, was just anecdote, like not unvalidated assumptions that different actors had. And so I pretty much went around the whole supply chain of seed systems and integrated government opinions from people who are monitoring the system, and scientists, farmers, multiplication organizations, and breeders. And then I used an ontological framework, right, to organize all of these different informations and into resource system, resource units, governance systems, and actors, and also what was, so to say, going on in actual interaction and outcomes. And from these different variables, I then try to derive what was going on in the system. And from my result, from my data, I got that the decisive thing going on was the governance of information that determined breeding, contracting over multiplication areas, and seed selling. And the governance of information, for example, for the contracting over seed means that multipliers do not use any complicated mathematical tool, as you would probably assume when thinking about how much multiplication area they want to get out there, but they are rather acting on, so to say, intuitive formulas that are also influenced what's being recommended by the straight variety trial conductors. And that again brought about another question for me, where I was like, okay, how well does the system actually work? What is the effect of pest shocks on seed multiplication portfolios? And now, as you can see, compared to beforehand, we're looking at a very tiny error, so to say, within this whole overall system. The underlying intuition to this is that as the climate changes, this brings about a change in temperature and precipitation patterns. It also induces changes in pest patterns. And farmers counter these aside of spraying by using pest-resistant varieties. But the problem that you have with these pest-resistant varieties is that pests mutate over time and breach resistances again. And that brings about pest shocks. And for all of the plant breeding people present, right, you know this. There is the Red Queen cycle from Lewis Carroll is usually used as a metaphor here. So the underlying hypothesis here was then that multipliers, so the people who produce the seed adopt the variety portfolios, speaking like how much of each variety they produce, right, when shocks and pests occur. So our underlying null hypothesis then was that the multiplication area of resistant varieties does not change, right, because we want to falsify this when a pest shock occurs. Another variable that I added to my empirical inquiry was also whether the recommendations by the state variety trial actually had an impact on the multiplication area allotted, right? And the underlying notion here is to figure out whether the governance in this case, right, has an impact on what the individuals do. Here we see the state variety trial places from which we have our data for the different for the scoring of the different varieties, where the trials are at, and how they are distributed across the different pedoclimatic zones. Our empirical approach with that was that the underlying notion is that we wanted to find a pure effect on the multiplication area. And in order to do that, we used something that's called difference in difference approach, where you assume, right, like that you would have been on a parallel trend beforehand if the pest shock hadn't occurred, and then the multiplication area of the varieties with resistance goes up. And that's effectively what we're estimating in these these estimation windows between one and then different time periods are called 2x2s. And we estimated that for each disease. And our identification strategy effectively was that I applied a sorting algorithm of sorts in order to find my shocks in my data, and then use only those time periods for my analysis where I had clean shocks, right? Because if you use, so to say, double shocks, you have an empirical problem that's described by Goodman and Bacon, where you then will either over or underestimate your results, especially if you're looking for that initial difference as soon as a pest occurs. So effectively, I did that with an algorithm that handpicked those 2x2s for me. And then I added the additional covariates to my final estimations, like life cycle of the varieties, the weed quality categories, and the governance variable, which is called a dummy because it was either a recommended variety or not. And then we looked at the results. And that is the exciting part. So as you can imagine, that is a lot of there is a lot of stuff coming around, but especially if you run this for multiple diseases, and you do robustness checks with lags and different categories for resistances. And then when we're looking at our results more closely, so to say, right, and here we're zooming in for a couple diseases. Yeah, we effectively did not find a real indicator that the pest shocks themselves had a real treatment effect on the variety multiplication areas if you took all of the other variables into account. And that seems, I guess, not so cool at first, but the governmental recommendation of varieties was very significant. So what does that effectively mean? Well, it means that the governmental recommendation for different varieties works, actually, that the multipliers are reacting to the recommendations, and that this has a sizable effect on the multiplication area. And as we see from the depicted confidence intervals here around those means, right, and we tested here against 0, that means that the effects were also sharp. Yeah, so yay for our governance. There is governance active in the seed system. Yeah, so panning out again, the pest shocks as we imagined them did not have such a great effect, and it was more the government's, or in this case concretely the recommendation activities conducted by state variety trial conductors that drives the seed supply within Bavaria. Yeah, and overall that means that we need to very carefully think about what kind of information we're supplying in the future. It is also very important I would say, in the face of climate change and other productivity challenges that we're running into, that make it very important that new varieties are being distributed throughout the system, that we are actually supplying solid information that can then move this whole system into the right direction. So for my thesis overall, I had multiple, so to say, areas where I have, so to say, contributed teeny bits to the knowledge that's already out there, I want to say, on like what's out there to know, how we can know what's out there, so to say, right? As in like what we saw when I operationalized the SCSF, which is the social-ecological systems framework earlier in the chapter 2 paper, or for a methodological example, right? Like what we just saw with like how do we introduce new data sources that are usually not used in agricultural economics, and apply counterfactual thinking to them. And what does that concretely mean for our methods, right? Like here we saw the example of the interviews earlier. And then there is a lot more that we could also talk about, but you can talk to me about this after this talk. Well, and then I went on to Cornell, and currently I'm, so to say, looking at productivity gains in the face of climate change. And it is, right, as Maria Skłodowska said, one never notices what has been done, one can only see what remains to be done. And there is a huge research agenda ahead, at least from my perspective, what can be done around social, ecological, technical systems, crop resource, genetic resources, the governance of it, and research and development in agriculture in general. Thank you so much for listening to me today.